Hello, I'm Katie Hockman. I'm really happy to be back at GopherCon, speaking with everyone again. So I used to work on the Go team back in 2018 at Google here in New York. And then I worked at Datadog with Felix and Hannah, where I worked on the Go tracing libraries team. And now I've continued my journey with Go. I've actually moved over to Tokyo, Japan. I'm working on the platform team at Mercari, which is Japan's largest C2C marketplace. I'm working on Go standardization there. So I'm at GopherCon today to talk about more AI, but I promise it's going to be fun. I'm going to talk about some new developments in the AI technology space and introduce you to the new official Go libraries that are going to empower you to develop this technology yourself. So I know that there have been a lot of AI-related talks at GopherCon this week, but like many of the others, I'm not here to tell you that AI is going to solve every single one of your problems. I want to stay really focused on a very specific single technology that you can write and use to make AI more effective and share some really practical applications of it. So today, we're going to be talking about the Model Context Protocol, which is MCP. Which is an open standard protocol for AI systems. And we're going to spend some time. I'm going to do a live demo, so wish me luck on that. Let's get started. So just first, a reminder of why you should care about this, even if you aren't a power user of AI yourself. So that's the 2024 Stack Overflow Developer Survey that says 76% of programmers are currently using or plan to use AI for coding this year. This was also confirmed by the Go Developer Survey last year too, which said that the majority of respondents, about 70%, are also using AI assistants when developing Go. So it's important to meet your users where they are. However, these users are going to face problems, and a lot of these have already been talked about in the last couple days. AI is often hallucinating, giving inaccurate information, or even when it is right, it's not really the best answer, or it's too generic to really be helpful. And AI tooling has limited power on its own. It can really just kind of search things, regurgitate information. It can't do that much on its own. And for example, Alan's talk yesterday, he was demonstrating AI's unwillingness to use new Go features when vibe coding, even when it knew that they existed. So it was technically correct, but not really the best solution. So most modern IDEs now have the ability to interface directly with language learning models, or LLMs, within the UI. We're going to be calling these the IDE's AI agents. And it's what you used before if you've ever done vibe coding in your IDE. So for those who have tried it before, you may have found, though, that it really wasn't as powerful as you would have liked. Out of the box, it can really only access whatever is in your local IDE or maybe perform a basic internet search. It can be unwieldy at best and actively unhelpful at worst. So if you ask it to update your company's dev database or deploy your software to staging or ask it something kind of company specific, it's going to struggle. It's probably going to fail. Enter MCP servers. This is the kind of problem that it's built to solve. So the main problem with those previous examples is that the AI agent within the IDE didn't have the necessary context to do what was asked. And it didn't have sufficiently powered tooling to perform those useful actions. And this is where the tools provided by MCP servers are going to come in handy. So introducing the Model Context Protocol. It's a brand new open standard of communication within an AI system. It was published less than a year ago in November of 2024. The MCP framework is going to help improve the accuracy of LLMs, tailor them to the needs of your organization or your user base, and equip LLMs with the power to perform useful actions within your system. So in simple terms, MCP is a protocol for AI models to interact with external tools. So you can imagine it like a universal system agnostic language like TCP or HTTP, but for AI applications, enabling them to interact with tools outside of an AI environment in a consistent way. So let's talk through a practical example of what I mean. Let's imagine we're running Kubernetes commands and experience a sudden crash. I'm sure no one here has ever had an error with Kubernetes before. In an AI environment with the proper MCP server tools installed, this may be as simple as just asking. So for example, you're in your IDE, you ask your AI agent something like, hey, can you create an issue in the Kubernetes repository that describes the bug that I just encountered? So the AI agent has to do a lot to solve that problem. it has to perform a number of actions and gather information from various sources to achieve it. So for example, well, what bug just occurred? What even is Kubernetes? What repo is Kubernetes in? It has to format the bug. It has to actually create the issue on GitHub. Then it has to give the link back to you that it created. Some of that it can do on its own using local state or what's inside of the agent. But things like the repository, it doesn't know what that is. It's going to have to interact with GitHub. So those questions like which repo is Kubernetes in and actually creating the issue itself, it's going to require interfacing with the GitHub platform. The AI agent can do this through tools provided by the GitHub MCP server installed in your environment and configured with your GitHub credentials. This is actually already available. You can use it today. It's free. There's a GitHub MCP server that you can download if you want to experiment with it. And when you look at it, you're going to notice that these MCP tools look a lot like API functions that a typical server would expose. It can do things like create or list issues. It can get pull request details. It can search. It can create branches. The difference is that rather than you having to handwrite code that calls every single relevant API, that takes a lot of time. You have to understand the full API surface. That's the AI agent's job, is going to figure all of that out for you. So at our original example, again, let's imagine now we have a ton of MCP servers that are going to help us. So for example, maybe you have MCP server A. That's going to be spun up by your IDE, and then it's going to automatically connect an MCP client to it. So now when you ask it to update a database, it's just going to do it for you using the MCP server A that can help. Or imagine you ask your IDE's AI agent to build and deploy your code. Well, maybe you have MCP server B that has credentials configured to interface with GitHub and GitHub Actions and GitLab in the way that's specific to your organization. Or imagine you ask that company's specific question that's not available on the public internet. Or you already have an HTTP server that's running on your company's cluster, and you just want to be able to interface with it in your IDE. Maybe MCP server C is just a very thin wrapper around this HTTP server, which can help the agent by speaking the model context protocol. So in short, LLMs empower users to perform actions using human language, and MCP servers empower the LLMs to be more accurate and targeted. So maybe you have an idea already for an MCP server that you want to build, but you're a Go developer. You want to do it in Go. Well, I have good news. The Go team is currently planning with the open source community to build an official Go SDK for MCP servers and clients. So as of the time of this talk, August 2025, it's V0.3. I think that was released just Friday, so it's really under active development. They're planning on releasing V1 soon, so it's actually a really good time now to beta test it and try it out and give feedback while it's still able to be changed. All right, so we're going to go bold here, and we're going to do a demo live with an AI agent, so wish me luck. The code's there, but the bandwidth here is going to be tough, so don't do any internet searches for the next 15 minutes. Help me out. All right, so what we're going to be doing together is we're going to build an MCP server that interfaces with the GopherCon agenda so that you can get really good information about GopherCon. I wrote some code in advance. You don't need to know the details of it. I'll just briefly explain it. This is just a sessions.go file. It essentially just spins up a virtual browser that then scrapes all of the sessions that are on the GopherCon website, spins up some Go routines and some workers, and then when it finds a page, it just looks for specific elements on the page, and then it puts it into this session struct. So this is all of the metadata it has about a GopherCon session, like the ID, the title of it, the date, when it's happening, who's giving the talk, things like that. So that's already available, and then I have an offline copy so that I don't have to try to parse the whole thing live right now. So I'll be running in like offline mode for the demo. So I want to first I'll be showing both Cursor and VS Code so that you can see it in a couple different ways. I know that Golang also supports MCP servers. So this is what Cursor looks like with no MCP tools installed. So you get to that by going to Cursor settings, and then MCP and integrations. So there's no MCP tools installed. Let's just test this out and see how it behaves without anything. So tell me about GopherCon this year. All right, it tried. Yeah, it's like, okay, it's in San Diego. Apparently we're all in California right now. Welcome. It's not really right. It's kind of generic. So it tells a few things, but I think it's probably hallucinating some of this. So it's going to be our job together to help it do a better job. So let's go ahead and create our MCP server. So if you've built an HTTP server before, it actually looks very similar, where you define an MCP server. So I'm going to be using this library here. It's Model Context Protocol /Go SDK /MCP. This is where all of the SDKs are for all of the MCPs. And this is the one that the Go team is working on. Okay, so I've defined my MCP server. I've called it GopherCon 25, and I've given it a title. This is going to be used by both you as a user and by the AI agent to know what it does. And I'm going to go ahead and start the server. So let's do a little log, and let's start it. So I'll run server.run with context background. And this is just the transport that the MCP client and the MCP server are going to be using to communicate. This is probably fine in most cases, but you can mess with it if you want to be able to see more useful logs, if you're building one yourself and you want to test it. And if there's an error, we'll just panic. Okay, that's it. That's all the code we need. It's very, very little. This is just some stuff to load the sessions. So I did write a script to make it easier, but it really doesn't do very much at all. So I'm going to be installing it into Cursor. You probably just noticed this green dot came up. So all this install script does is basically just run go build, and it puts that binary in the build directory of my local copy of the code here. And then it spits this config into Cursor. So I've installed it, and I want to show you what it looks like in Cursor now. So remember before this said no MCP tools installed. Now we have one. So we have GopherCon 25. And you can see the little green dots. So green dots are always good. It means no errors. So let's go ahead and look at the config. So you'll notice that this is in users/kmh. This is my home directory. And within your home directory, there's going to be a .cursor directory. This is going to be global configuration for Cursor that applies to all instances of Cursor that you have running on your machine. So if I spun up a new instance right now, it would have the same config. And then there's an mcp.json file. This is where you define all of your MCP servers. For now, we just have one, GopherCon 25. And you can specify a number of things here. You can do access to remote MCP servers that are running on other servers than your own machine. I have it just running my local binary. So this here is the same binary here. So I'm asking the IDE to spin up this binary in a sidecar, basically, and connect to it. Okay, so right now it says no tools or prompts, so let's make a tool. Okay, so let's add this. Similar to like an HTTP handler on a server, you're going to be doing an MCP tool on the MCP server. So I'm going to connect this with the server that I just defined, and then I'll work on MCP tool. So it's going to be called list sessions. And it lists all of the GopherCon 2025 sessions with all of the information it has. So let's define this handler here. Great. Okay, so now we have a handler function. And it's cool that this is available. It uses generics. So I can define both the parameter struct and the output struct. So I define both input and output, which is really great. It provides you a lot of flexibility. For a list, there aren't any parameters that need to come in, so I'm just leaving that blank. But this is the output I defined, and I defined it as a sessions result struct, which just has a single field, which is a slice of sessions. So this is going to be a bunch of the agenda that was parsed. You'll see that my code is very, very little. It just returns the sessions result with a nil error. All right, so we've done just a tiny bit of code. Let's go ahead and rebuild it. Okay, let's restart our server. Hey, we have a tool enabled now. It's called list sessions, and it has that same information that I defined. So let's see how it works now that we have a new MCP server. So you'll notice that before it just kind of made something up, but now I didn't have to tell the AI agent to use the tool. It just kind of guessed like, oh, I have a tool, maybe it's gonna help me. And it's going to figure out the protocol that it needs to use, and it's going to figure out the parameters, which in this case, it knows there are none. So let's go ahead and run that. You're going to notice it has a lot of information here. It's just tons and tons of JSON. And now it has the context that it didn't have before. So it's going to be able to give a much better result. Hey, we're in New York now. We're no longer in San Diego. Congrats. So it's going to give me really detailed information about this talk. Now what's really cool is it has this context. All of that context is going to be saved in this chat session, so it doesn't have to ask again for the same information. So I can ask follow-up questions like, is Filippo giving a talk? And it's going to be able to just figure it out based on the context it has. Said, yeah, Filippo's giving a talk. I think this is some old data that I had before. But yeah, we get to see the whole agenda, and I can say, hey, create an agenda for me of the free included AI talks. So maybe I want it to omit workshops, for example. So it can do that. Great, and it knows based on the data it had whether or not a separate ticket was required. So very little code, we already have a much better answer. In a number of situations, list can't actually give all of the information. Like imagine you have a database with like tens of thousands of rows, and you really only want list to give a subset of those columns. So maybe you only want it to give ID and title. So let's just pretend I've changed this code to only return a list of just the sessions with the ID and title included and the rest omitted. So in that situation, we're going to want to have another tool. This is a tool that is going to take a parameter because it's going to need the ID. So it's going to get detailed information about a specific GopherCon session by ID. So let's go ahead and create that one. Okay, so it looks really similar to our list sessions, but you'll see one key difference. Before, this was just a blank import here, a blank identifier with any. Now we have this param that I defined. And this is the session ID param struct. It has a single field, session ID, and then I can use that inside of my function to figure out, do a lookup essentially. Does it exist? If it doesn't exist, I'm gonna return an error. And if it does exist, then I'm gonna return it with just a single sessions result with one session in the list. All right, let's rebuild our code again. We'll restart our server. Now we have two tools. And what's cool about Cursor is you can actually toggle these, so I can turn these on and off. So for example, if you use the GitHub MCP server, maybe you only want to have the get tools available, but you want to remove tools like create a release, for example. So you can toggle that, which I think is really helpful. All right, let's test it again. So it decided to use list sessions again. But now, let's see what happens if I ask, is Felix giving a talk? It has to give me a lot of information, apparently. Okay. So this is what's really cool. It had the context before, which was that huge chunk of JSON. And when I asked about Felix, it was like, oh yeah, I've seen Felix before, and in the speaker list associated with this ID, and then I'm gonna look up in this ID, there's a get session detail, so maybe this is gonna give me extra information, and it can do that now. And let's pretend that it didn't have that information before, now it has it. It can also handle errors pretty well too, so I can say, tell me about session. I can just give a random ID. And it's gonna try and it's gonna fail, so you'll see it returned an error. And it's gonna tell me, sorry, I can't help you with that. So that's it for Cursor. I wanna just briefly show you what it looks like in VS Code. So I have a very similar script for VS Code that it just installs it and puts it in the relevant file to configure VS Code globally. So this is actually already in your VS Code instance. You may not have seen it if you haven't used it before, but everyone has used the extensions likely if they've used like the Go extension, for example. Now we have a GopherCon 25 server installed, and it looks like this in the configuration. So it's very similar to the Cursor configuration. So let's go ahead and start it and just see what it looks like here too. So if I say, tell me about GopherCon, it's gonna do this. Oh, see, this is what happens with live demos. Try again, maybe? Okay, it decided to be nice this time. Saw my desperation. Okay, so it worked the same way. So same experience, different editor, and it was all the same code. So that's really cool. So what did we just see? In just a few minutes, we wrote an MCP server in Go. We exposed it to both Cursor and VS Code, and we gave the AI actual knowledge about GopherCon so it could do a better job. But you might be asking now, why did we do this in an IDE? Today's example wasn't code related at all. But imagine MCP servers that are tied to your code. For example, there's already an MCP server out for Go Please that's in beta. That's going to be really helpful if you're in your IDE environment to get information about your code. Or a custom static analysis tool, or a migration tool that can guide users step by step as they write their code, things like that. And the best part is you can do all of this in Go using an IDE agnostic library to develop it. So it should be fast, it should be simple, and it should be familiar to you if you've developed servers in the past. And that's our demo. So to wrap up, the real value of MCP is that it gives AI agents structured, reliable access to the tools and data that it can't guess or hallucinate. So we saw a demo of this today with the GopherCon schedule, but you can imagine using the same pattern for CI/CD tools, code analysis, or your company's own APIs. Notice how the agent's answers improved only after we gave it structured tools via MCP. That's the difference that MCP makes. So Go supports MCP, MCP supports AI agents, and then the AI agents support you. My closing thought is this. I want you to all think about the capabilities that you wish your IDE had when you're developing your Go code. With MCP and Go, you don't have to wait for somebody else to build them. You can do it yourself. Thank you so much.